Okay, so in this module, we'll be talking about physical properties that relate to the periodic table and the various elements. So firstly, there's electronegativity, and electronegativity is essentially um, the strength of an atom's attraction to electrons. Um, it this is dependent on the atom's nuclear charge, and based on trends, electronegativity decreases down a group. Um, the most electronegative atom is fluorine, which has a very high electronegativity, and this makes sense due to the fact that it's a halogen, and because halogens require an extra electron to become a noble gas. Um, and then using the prior information, as the electronegativity decreases down a group, we'll see that going down the halogen group, the degree of attraction to electrons would decrease. Then further utilizing this theory, we would understand why the lowest electronegativity values come from alkali metals, because they would not like to attract any electrons. In fact, that's the last thing they would want to do, because they would be keen on donating or giving away an electron so that they can become noble gases. So the next, it's also important to understand that electronegativity increases across a period, which is the horizontal way of looking at the periodic table. And this also makes a lot of sense, because as we move across the periodic table from left to right, we would see that the attraction to gain extra electrons to complete the shell would increase. Okay. And something I didn't write down, but is very important, is first ionization energy. Okay, so first ionization energy is the amount of energy required to remove the outermost electron from a gaseous atom. That is, this can be expressed through the following process. So, for example, we'll have magnesium, and of course it exists in the gaseous state, becomes M plus, or sorry, manganese, my mistake, M plus, also in the gaseous state, plus an electron. So this is the first ionization energy, because it's been ionized to the first degree by removing a single electron from the original element in the gaseous state. So the amount of energy required to conduct this procedure is known as the first ionization energy. So based on chemical theory, the first ionization energy is set to decrease down the group, and this is due to the fact that nuclear charges are stronger. Oh, sorry, my microphone was malfunctioning. Okay, we'll move on to the next important physical property, which is atomic radius. And atomic radius is essentially used to describe the size of an atom. The larger the atomic radius, the larger the atom. The atomic radius essentially measures the width between the electrons on either side of the orbital. And it's not measuring from the width of the neutron, but the width of the entire atom as a whole. So atomic radius is set to increase down a group, which means that as you go down a group, it's set to become wider. This makes a lot of sense, because with going down a group, it's the same number of valence electrons, but a different number of shells, or valence shells. And with an extra moving down one level, you would have an extra shell, and this extra shell would lead to a higher or a larger atomic radius. Then the following physical property is ionic radius. Ionic radius is slightly different because it's the measure of the size of an ion. And of course, ions are different to atoms because ions are charged particles, whereas atoms are the neutral or non-charged versions of the element. There's a key tip to remember, or key rule of thumb to remember for ionic radius, and that is the ionic radius of positive ions are smaller than their atomic radius, whereas the ionic radius of negative ions are greater than the atomic radii. To understand this, we'll need to consider the fact that a negative ion includes one electron more, because if it's a negative ion, it would have attracted a negative charge, which is indeed an electron. And with more electrons, there's a greater width between the charged particle, between the electrons and the centrally positively charged nucleus, due to repulsion forces, also known as shielding. Whereas a positive ion is, of course, when an electron has been removed from the atom, and with the removal of the electron, there's an electron that has been lost either to another atom, or it's not present anymore in the element we're looking at, and there's a lesser negative charge between that and between the negative charge. There's a lesser negative charge, and compared to the positive charge of the nucleus, the positive charge is outweighing that negative charge, and thus is leading to its contraction, which is why the ionic radius would be shrinking slightly, and hence it would be shorter or smaller compared to the atomic radius of that particular atom. Then finally, melting point. Melting point is essentially the point at which an element in its standard state would melt. And of course, melting is the occurrence of when the solid state of that atom turns into the liquid state. So the trend that relates to the melting point of group 1 is that it decreases as you go down the group. This is because the atomic bonding within these elements are metallic. The solid is held together due to an electrostatic attraction between the positive ions and the electrons, the positive ions that derive from the nucleus, the central nucleus. So then, as the attraction between the electrons and the positive ion increases, it requires more energy to break apart due to the stronger electrostatic forces, and hence lesser energy, my apologies, and hence there's lesser thermal energy required to break these bonds, and therefore a lower melting point arises. However, when comparing group 7, halogen atoms do not possess a metallic bonding. Instead, they possess a weaker bonding force known as van der Waals forces. And these forces, and the same concept applies in the sense that thermal energy is supplied to them, which in turn denatures and breaks the bonds, which converts or transforms the halogen from becoming a solid to its liquid state. However, for halogens, the melting point would increase as you go down the group.